Hello there, welcome to the October 2020 paper 2. Here we're looking at question 2. In an Argand diagram, the points A and B are represented by complex numbers -3 plus 2i and 5 minus 4i respectively. A and B are the points at the end of a diameter of circle C. Write the equation of C, giving your answer in the form z minus A equals B. Okay, well first of all let's draw a little diagram to visualize this diameter. So it's -3 plus 2i, -3 plus 2i, and the other point is going to be at 5 minus 4i. 5 minus 4i. Now the midpoint here is going to be the center of the circle, so the middle value between -3 and 5 is going to be -1, and the middle value between 2 and -4i will be -1 as well. So no, the first bit's 1, and the second bit's -1, so effectively it's 1 minus I. So there we are, that's the midpoint. So therefore, and we need to now work out the circumference, sorry, not the circumference, the radius as well. So that's going to be 4 across and 3 down, so it's a 3, 4, 5 triangle. So it's going to have a radius of 5, so therefore it's going to have the equation z minus 1 minus I equals 5. So therefore when we expand this bracket, it's going to be z minus 1 plus I equals 5. And there we are, that's the answer for question A. Let's move on to question B now. So circle C was z minus 1 plus I equals 5. The circle D with the equation z minus 2 minus 3i equals 2 intersects C at the points representing the complex numbers z1 and z2. Find the complex numbers z1 and z2. Okay, well basically what this is here is it's a bunch of simultaneous equations. For curve C, which was this one here, it's going to be x minus 1 squared plus y plus 1 squared equals 25. And for D, it's going to be x minus 2 squared plus y minus 3 squared equals 4. So it's basically these two simultaneous equations here that we now need to solve. So if we expand the brackets on C, it's going to be x squared minus 2x plus 1 plus y squared plus 2y plus 1 equals 25. So we could probably tidy this up to x squared minus 2x plus y squared plus 2y equals 23. And on the second one, it's going to be x squared minus 4x, and then it's going to be y squared minus 6y, and then we'll have to subtract a 9 and subtract a 4, so it's going to equal minus 9 on the right hand side. So now let's subtract these equations one from the other. So if we do equation 1 take away equation 2, then that's going to give us x squared take away x squared will cancel out. Minus 2x minus minus 4x will give us 2x. Y squared will cancel out with y squared. 2y minus minus 6y will give us minus 8y. And 23 minus minus 9 is going to give us 32. Oh no, sorry, this is a plus 8y because it's 2y minus minus 6y, so it's a double negative there, so it makes it plus. Now let's now divide through by 2, so it's going to be x plus 4y equals 16, so therefore it's going to be x equals 16 minus 4y. So now what this line here is the equation of the line that will go through points z1 and z2. So what we need to do now is just couple it up with one of these simultaneous equations from before, and substitute one into the other. Maybe we'll call this equation 3, 3 into 1, and then we can then solve that equation. So let's go ahead and do that then. So 3 into 1, so it's going to be 16 minus 4y squared minus 2 lots of 16 minus 4y plus y squared, plus y squared plus 2y equals 23. Okay, let's expand the brackets now. So 16 squared is 256 minus 128y plus 16y minus 32 plus 8y plus y squared plus 2y equals 23. Okay, let's now simplify it and bring it all onto the left. So it's going to be 16y squared. So it's going to be 17y squared. And then for the y's, it's going to be minus 128. And then it's going to be add 8. And then it's going to be add 2. So that's going to be minus 118 y. And then it's going to be on the numbers 256 minus 32 and minus the 23 as well. And that gives us 201 equals 0. So let's now solve this in the polynomial equation solver. So mode A, polynomial degree 2, 17 minus 118, 201. And we get an answer of, well, it's not a very nice answer, 67 over 17, and y equals 3. That's a bit of a nicer answer. So now let's substitute both of these answers into the equation of the straight line. So therefore, if I save the first one as A and the second one as B, get back to my normal mode on the calculator, then it's going to be 16 minus 4 lots of A, which is 4 over 17, and the second one is going to be 4. Lovely, so there we are. So the coordinates of the intersection are z1 equals 4 over 17 and 67 over 17, and coordinate 2 is 3, 4. So there we are, that's the answer for this question here. Quite a tricky little solving simultaneous equations one there. It did take me a little while to puzzle this one out, how you solve the intersection of two circles. But yeah, you just subtract one equation from the other, and that will cancel out both the x squared and the y squared, to leave you just with some linear terms, and then you plug it back into one of the other circles, back into one of the first circles, and then solve it. So there we are, that's the answer for question 2, worth 9 marks in total there. Let's now move on to question 3.